Welcome back, deep divers. Ready for another fascinating journey into the world of science?
Always ready.
Excellent. Well, today we're going deep into the immune system.
Ah, the immune system, a classic.
Absolutely. But we're focusing on something specific, those tiny but mighty molecules you might have heard of, chemokines and cytokines.
Yeah, those terms get thrown around a lot.
They do. And honestly, they can be a bit confusing.
No doubt. Lots of interleukins to keep straight.
Exactly. So to help us navigate this microscopic world, we've got a fantastic article from Assay Genie. It's called Chemokines versus Cytokines, a detailed comparative study.
Sounds comprehensive.
It is. And get this, it was written by a PhD student in zoology. So you know we're getting solid scientific info here, ready to decode the language of your immune system.
Let's do it.
All right, so let's start with chemokines. What are they, and what makes them so special in the grand scheme of our immune defenses?
Okay, so chemokines. They're all about precision. Imagine, right? Your immune system needs to mobilize its defenses.
Right, send in the troops.
Exactly. But it can't just be a chaotic free-for-all. Chemokines are the signals that direct those defenses with pinpoint accuracy.
Ah, so they're like the traffic controllers.
Yeah, perfect analogy.
Okay.
They're guiding specific immune cells to the exact spot where they're needed. Not just a general call for help, it's strategic deployment.
So it's less sound the alarm and more, okay, Squad B, you're up. Go to Sector 4.
Exactly. And this targeted approach, it's a big deal for researchers. Think about the possibilities for targeted drug delivery, sending medication right to the site of inflammation or infection.
Whoa, like a microscopic GPS system for medicine?
Exactly.
That's incredible. Now, the article mentions 4 families of chemokines, CC, CXEC, and CX3C. Admittedly, they sound a bit like alphabet soup to me.
Yeah, the names themselves are a bit technical. They're based on the arrangement of something called cysteine residues.
Ah, the chemistry part.
Right. But don't worry, no quizzes here. The important thing is each family specializes in attracting different types of immune cells. They have their own specialty teams.
So it's not just one type of chemokine doing everything.
Nope, they're specialized. It's like having different units for different tasks. Makes the whole system much more efficient.
Makes sense. So we've got our chemokines directing traffic, make sure the right cells get to the right place. Now, what about cytokines? They seem to play a broader role, right? More like a communication network.
Absolutely. Think of cytokines as the town criers. They're spreading the word about anything going on in the body. Could be an infection, an injury, even just routine maintenance.
So they're keeping everyone informed.
Exactly. And cytokines. It's a much larger family of signaling molecules than chemokines. They're involved in all sorts of activities, regulating inflammation, cell growth, even how our immune system responds to specific threats, like viruses or bacteria.
Wow, so they're really multi-talented.
Oh, absolutely. We're talking familiar names here, too. Interleukins, interferons, remember those from cold and flu season?
Oh, yeah, interferons. Always popping up in those medicine commercials.
Right. They're known for their antiviral properties, literally interfering with viral replication, and interleukins. They're a huge family with incredibly diverse roles. Some amplify inflammation, some suppress it, some activate specific types of immune cells, others fine-tune the overall immune response, preventing things from, spiraling out of control.
It's incredible how these little proteins do so much.
It really is. They're tiny but mighty, that's for sure.
Okay, so we've established both chemokines and cytokines are vital for a healthy immune system. But where do they differ? If we were to put them head to head, what would be the key distinctions?
All right, the tail of the tape. Well, both are essential for communication, no doubt. But the main difference is in their primary function.
Okay, so what's the main gig for each of them?
Chemokines. Movement. That's their thing. Attracting cells to specific locations. They're the guiding force behind immune cell migration.
So they're the ones saying, this is the place, folks. Party's over here.
Yep, exactly. But cytokines, they're more about the overall immune response, regulating cell growth, differentiation, modulating how the immune system reacts to different challenges. They're more like the general contractors, I guess, overseeing the whole project.
So chemokines bring the workers, cytokines mans the project.
Perfect analogy. And even though they have these distinct roles, their functions can overlap. They work together, sometimes even synergistically, to make sure the immune response is coordinated and effective.
So it's not just a clear-cut division of labor. They collaborate.
Definitely. They have to make sure everything runs smoothly. It's a complex dance, really.
It's fascinating how much we can learn about our bodies just by focusing on these tiny molecules.
It's like zooming in on a whole world we never knew existed. And the more we learn, the more we realize how much more there is to discover.
That's the beauty of science, right? Always more to learn. And speaking of learning, I'm ready to dive deeper into the specifics of these chemokines and cytokines.
Let's do it.
All right, so we've laid the groundwork. Chemokines are cellular traffic directors guiding those immune cells, and cytokines, the master communicators, broadcasting vital info throughout the body. But let's get specific. We talked about those 4 chemokine families. What kind of missions are they handling?
Right, so think of each family as having their specialty. Their own team of immune cells recruited for specific tasks, like take CC chemokines, for instance.
CC chemokines, okay.
Yeah, incredibly versatile, attracting a bunch of different immune cells, like monocytes, T lymphocytes, to sites of inflammation. They're like that all-hands-on-deck signal.
When there's trouble brewing.
Exactly. Infection starting, injury. CC chemokines are sounding the alarm.
Got it. So then what about the CXC chemokines? What's their specialty?
CXC. Some of them are specialists in attracting neutrophils.
Neutrophils, remind me.
Think of them as first responders, quick to arrive at the scene of an infection, start fighting.
So they're rushing to put out the fire, so to speak.
Precisely. But there's this other fascinating thing about CXC chemokines. Some of them are involved in angiogenesis.
Angiogenesis.
Formation of new blood vessels.
Right. Important for healing.
Essential for wound healing, tissue repair, but, it can be a double-edged sword.
How so?
Well, tumors, they can hijack this process to fuel their growth.
So not always a good thing.
Unfortunately, no. Highlights how complex these systems are. Even processes meant to heal us can sometimes backfire.
That's a little unnerving, to be honest. Okay, so we've covered CC, we've covered CXC, we've got 2 more families to go. C chemokines, what do they do?
C chemokines, these guys are a bit more specialized. They mostly attract lymphocytes. And lymphocytes, if you recall, they're key players in adaptive immunity.
Adaptive immunity, that's the one that remembers past infections, right?
Yeah.
So we don't get sick from the same thing twice.
Precisely. It's like our body's long-term memory for fighting off disease.
So like, I get chicken pox once, and then, thanks to adaptive immunity, I'm good to go.
Exactly. So these C chemokines, they're like the intelligence agents, gathering info about the enemy, remembering it for future encounters.
Wow, our immune system has memory. That's pretty amazing. Okay, that brings us to the last family, the CX3C chemokines. What's their deal?
This family's interesting. Only one member, fractalkine.
Fractalkine. Sounds kind of sci-fi, honestly.
Right. But what's cool about fractalkine is it can exist in 2 forms. It can be soluble, just floating around, attracting cells, or it can be bound to the surface of other cells, acting like a sticky trap.
So kind of like a double agent. Versatile, ready to act in different ways.
A great way to put it.
Okay, so that was a whirlwind tour of chemokine families. Now, on to cytokines. We talk about how they've got a much wider range of functions. What are some of the key players in that family, and what are they up to?
Right, so cytokines, remember interleukins, huge diverse group. Some of them, like IL-1 and IL-6, they're the big drivers of inflammation.
So they're the ones sending out the SOS when there's an infection or an injury.
Exactly. Triggering fever, recruiting immune cells to the site.
So they're responsible for us feeling sick, basically. All those classic symptoms.
Pretty much. But then you've got other interleukins like IL-10. These actually help dampen down the inflammatory response.
Oh, so it's not just a constant escalation.
No, it's got to be regulated. These IL-10s, they act like the brakes, prevent things from going too far, causing damage to healthy tissues.
Otherwise, we'd just be constantly inflamed, right?
Exactly. And then, of course, we have the interferons, famous for fighting viruses.
The famous interferon.
Right. They interfere with viral replication, activate natural killer cells.
Those sound intense.
They are. Natural killer cells are like the assassins of the immune system, and interferons also boost the adaptive immune response, which leads to, long-term immunity.
So they're really multi-talented when it comes to dealing with viruses.
Absolutely. And finally, we've got the growth factors. Living up to their name, they're essential for cell growth and division.
So they help us grow and repair.
Big time. Wound healing, tissue repair, development of organs. They're crucial for all of that.
So it's not all about fighting off invaders. They're also the builders and maintainers of the body.
Exactly. And just like chemokines, it's important to remember, cytokines can have both good and bad effects. Depends on the context.
Right, because too much of a good thing can be bad, as they say.
Precisely. Like inflammation is crucial for fighting infection, But chronic inflammation, driven by certain cytokines, that can lead to all sorts of problems, autoimmune diseases, cancer.
So it's all about balance, isn't it?
Balance and regulation, absolutely. And understanding how these molecules function, both on their own and as a team, that's key to developing new treatments for all kinds of diseases.
It's a little mind-blowing, isn't it? All this is going on inside us all the time. These tiny molecules, chemokines, cytokines, just battling it out. And we're usually completely oblivious.
It really is. Shows you the power of the immune system, right? Always working behind the scenes.
And what we've been talking about, researchers figuring out how to tap into that power, to reprogram the immune system. Sounds like science fiction, but it's happening.
Absolutely. It's an exciting time for immunology research. Groundbreaking stuff. We're not just treating symptoms anymore. We're starting to actually manipulate the mechanisms of disease.
That's incredible. The article we've been looking at, it focused mainly on chemokines and cytokines in the context of cancer. But it seems like the implications go way beyond that. What other areas of medicine are being impacted by this research?
Oh, it's huge. The potential is vast. Think about womb healing, for instance. Researchers are looking at using chemokines to speed up that process. Burns, injuries, surgical wounds.
That would be amazing, especially for people with chronic wounds,
Oh.
the ones that just don't seem to heal.
Exactly. And in organ transplantation, big area of research. Using chemokines and cytokines to prevent organ rejection.
That would be a game changer. For transplant medicine, preventing rejection would be huge.
Absolutely. And then you've got autoimmune diseases, rheumatoid arthritis, multiple sclerosis, seeing some really promising results with cytokine-based therapies there.
So in those cases, it's about dampening down the immune response, right?
Right.
Because it's overactive, attacking healthy tissues.
Exactly. It's like turning down the volume on an overactive immune response, trying to restore that balance.
It always comes back to balance, doesn't it? Finding that sweet spot where the immune system is doing its job, but not overdoing it.
Exactly. And the more we understand these chemokines and cytokines, the more tools we have to fine-tune that response.
So what's next for this field? Where do you see the most exciting opportunities? What are you most excited about?
Personalized immunotherapies. That's where it's all headed. Imagine treatments tailored to an individual's unique immune profile.
That's incredible, like truly personalized medicine.
Exactly. Maximize effectiveness, minimize side effects. That's the dream. And as we learn more about the immune system, it's becoming more and more realistic.
Well, this has been an amazing journey. We started with those kind of intimidating terms, chemokines and cytokines, and now we have a much better understanding of how these tiny molecules are literally orchestrating our immune defenses.
It is amazing. Just goes to show there's a whole world happening at the microscopic level, a world that's vital to our health.
And to wrap things up, what's the one thing you hope our listeners will take away from this deep dive?
The immune system. It's complex, it's powerful, and we're only just beginning to tap into its full potential. All this research on chemokines and cytokines, it's opening up whole new possibilities in medicine. Real hope for better, more personalized treatments for so many diseases.
And for those of us who aren't scientists,
Stay curious, keep learning. The more we understand about the immune system, the better equipped we are to make decisions about our health.
absolutely. Well said. It's been a pleasure diving into this topic with you. Until next time, deep divers, stay curious.